right, so this is Chapter 4, Lesson 6, Construct Functions. And we're going to learn about, we're going to analyze graphs, and we're going to analyze tables and functions written as words. So in the real world link, it says Dylan is planning to have his birthday party at a skating rink. The rink charges a party fee plus an additional charge for each guest. So let's see. The skating rink charges a party fee plus an additional charge for each guest. Okay? It says choose 2 points from the table and find the rate of change. Now remember, does it matter which 2 points we choose? No, it does not matter which 2 points we choose. So let's just choose the first 2. Okay, the smallest of the bunch. Okay? So, how do I find the rate of change again? Very good. The rate of change is equal to the delta y over the delta x. Okay? Rate of change is equal to the delta y over the delta x. All right, so using these 2 points, here we're going to look to see how the y changes. So we just subtract, right? So we're going to subtract 56 minus 53. That's the y values. Then we're going to look at how the x value changes. So that's 2 minus 1. So we end up with 56 minus 53, 3 over 2 minus 1, 1. Now, it says write a function to represent this situation. We can already start to write this equation with the rate of change in place of the slope. So our equation format would be y is equal to mx plus b. Okay? So we have the m, so y is equal to 3x. Okay? Now we just need to know what's that extra part. What's the b? How do you know it's 50, Caitlin?
Because the rate of change is 3 over 1, so it's 3 plus a party fee, which is...
Very good. So we have to add the party fee, which is $50. Very good. So 3x plus 50. And then you can double check that. How do you get from x to y? Well, here, we multiply this x times 3. That's 3. Then I have to get to 53. So we had to add 50 to it, right? Here, if I multiply 2 times 3, that's 6, right? And in order to get to 56, from 6, we had to add 50 to it. Does that make sense? And it works for all of the values of x. Now the third step is to graph the ordered pairs. And then it says, then extend the line of the graph until it crosses the y-axis. Okay? So we're going to graph each one of those points, 1, 53. Oh, what goes on the x-axis and what goes on the y-axis? The what? Number of guests go on the x, and the total cost goes on the y. Very good. The number of guests and the total cost. So here are our plotted points. Now when we put the line on there, look at where it crosses the y-axis. Where does it cross the y-axis? At 50, right? So here this goes on forever. Well, technically, theoretically forever. So here, the line crosses the y-axis at 50. What's my y-intercept? What's my initial value? 50. That's how much they charge to begin with, right? And then they add on a charge for every person. Got it? So that 50 where it crosses the y-axis is also my initial charge. Got it? All right, so the next example. We want to analyze graphs, words, and tables. Now it says the initial value of a function is the corresponding y value when x equals 0. You can find the initial value of a function from graphs, words, and tables. Now, it says the initial value of a function is the corresponding value when x equals 0. The initial value of a numeric function is the corresponding value when y equals 0. Again, the initial value of a function is the corresponding y value when x equals 0. Right? When x equals 0, that gives us the y-intercept. Very good. So this is also the y-intercept. Okay? So the initial value of a function is the y-intercept. Okay? The skating rink was started at $50. Sometimes you start at 0, right? Okay? So here, looking at the next example, Music Inc. charges a yearly subscription fee plus a monthly fee. The total cost for different numbers of months, including the yearly fee, is shown in the graph. And we want to find and interpret the rate of change and the initial value. So where we're going to get the information for our function is where? Charges a yearly subscription fee plus a monthly fee. So that's per month, right? That's where we get the beginnings of our. So we're going to start off always with the same format, y equals mx plus b, where the m is the slope or the rate of change, right? The slope or the rate of change. So we know how to find the rate of change. How do I find the rate of change? Delta y over delta x. Very good. So let's find the rate of change. So the first thing we found was the rate of change. Okay? We find the rate of change by subtracting our y values and subtracting our x values. And we chose, and it doesn't matter which ones we choose. You can choose any points you want that are on that line. Okay, so we end up with 3. So this 3 is the rate of change. Where does it go in my function? For m. Very good. So 3 goes here. And we're going to, the rate of change is $3 per month. Right? $3 per month. Now we need to figure out what's our initial value. So now we're going to choose an x and a y to put into our equation. And again, it doesn't matter which x or y you choose. You just pick one that's on the line. Okay, so I'm going to just go ahead and pick 1, 15. So again, with 1, 15, this is x, y. Right? So when I put this into the equation, y is, what's y? 15. X is 1, so 3 times 1. And now, I can solve for my b. Okay? So we've got 15 is equal to 3 plus b. And Caitlin, this is the reason why you would do that subtraction that you said. So we're going to subtract 3 here and there. So b is equal to 12. And B is your initial value, or your y-intercept, okay? And so the final equation would be y is equal to 3x plus b, which is 12. And there's your final equation. The y value represents the what? Total cost. Okay? And the x value represents here's the x-axis, the number of months. That is how you interpret the rate of change. You look to see what the y represents and what the x represents. Okay? This b, or the initial value, when we are talking about this particular example, what does that 12 represent? In this example, the b is that yearly subscription. You got it? The next example. A zoo charges a rental fee plus $2 per hour for strollers. Find the total cost of 5 hours, or let's see, the total cost of 5 hours is $13. Assume the relationship is linear. We want to find and interpret the rate of change and the initial value. All right, so the first thing we're going to look for is the rate of change, R of C. Rate of change. Now, I don't have a delta y or delta x here, but do you see in the words where the rate of change is? $2 per hour is our rate of change. Okay? So the rate of change is $2 per hour. So we can put that rate of change into our equation for slope. 2 goes right there. So here we have 5 hours is $13. Our rate of change is dollars per hour, right? So 5 represents the x. And of course, the $13 represents the y. Okay? So, if this is an x and this is a y, can I substitute in and solve for b? Yes. So, y is 13. X is 5. And now, we can solve for our initial value, b. You get that? So, here we have 13 is equal to 10 plus b. To get the b by itself, we will subtract 10. And b is equal to 3. So we have our slope, 2. We have our y-intercept, or our b, 3. Can I write the equation in slope-intercept form? Can I write my function? So y equals what? 2x plus 3. And there is your function. We know, let's see, it says interpret the rate of change. The rate of change is how much it costs per hour, right? The rate of change is cost per hour. And interpret the initial value. This initial value, $3, is what? The rental fee, right? And $3 is the rental fee. That's the thing that we're adding to the rate of change. You see that? The table shows the monthly cost of sending text messages. Assume the relationship between the two quantities is linear. Find and interpret the rate of change and the initial value. So it's the same instruction every time. The same instruction every time. So the first thing I'm going to find is the what? The rate of change, right? So the rate of change is my delta y over delta x. Okay? So again, does it matter which 2 points I use? No. But I'm going to go ahead and use those two. All right? So we subtract the y values. Subtract the y values and look at the change. So this is going to be $10.60 minus $10.50 over, now we're going to subtract the x values. So this is going to be 6 minus 5. So when we subtract, we get 0.10 over 1. How do I interpret the rate of change? The y value is what? It's the cost. There's the y value. There's the cost. And what's the x value? The number of messages. So when I interpret the rate of change, I'm going to say the rate of change represents the total cost, or the cost per message. Cost per message. That's how you interpret that. Do I have an x and a y to put in there to substitute into my equation to find my initial value? Yeah, I have 3 of them, right? I have 3 pairs. X comma y, x comma y, x comma y, right? You got it? So, does it matter which one I choose? No, it doesn't matter which one I choose. So, I'm going to go ahead and choose that one. X comma y. Okay? So, in my slope-intercept form, y is equal to mx plus b, we can substitute the 5 and the 1050 in for x and y. So y here is going to be 1050. My slope is what? Or my rate of change is 10 cents, right? My x from the table is 5 plus b. So we have 1050 is equal to 0.50 plus b. Then we're going to subtract 0.50. So b is equal to $10. So when we write our equation, we get y is equal to 0.10x plus $10. To interpret, we've already interpreted the rate of change. To interpret the b, okay, that is going to be your initial charge for having a service.